Okay, so today for this lesson, you are completing all of these slides on your own, and then afterward, we will go through them and you will check your answers with my answers. So by the end of this lesson, you'll have completed the study guide, and I've identified areas you need to study in preparation for the test tomorrow. You'll know you're successful when you can identify which areas you need to study, and you have a strategy in place to be successful. Okay. For question number 1, you're to identify which of these numbers below are rational and which ones are irrational and write them in the correct box. I'm going to start with 17 over 2 and solve that off to the side. 17 over 2 is the same as 17 divided by 2. And I'm going to do this by hand because we cannot use a calculator on this test. 2 goes into 1 0 times. 2 goes into 17 8 times. 8 times 2 is 16. Take it away, get 1. Create a decimal point and bring down the 0. 2 goes into 10 5 times. And we are done. So 17 over 2 is the same as 8.5. This is a rational number. And it's rational because it ends, right? We can write it as a fraction. It's already written as a fraction, and we can determine what comes next because we could just add a 0 to the end of this if we want to keep adding numbers, right? Next, we have 3.33. 3.33 is just completely full of 3's, right? But there is no repeating sign, which tells me this decimal ends right here, okay? And if it ends, then it is predictable and it is not irrational. So this is a rational number. Okay, next we have 15.1895407. This is a super long decimal, but there's no ellipses, there's no dot, dot, dot. There's no line over top that says it doesn't end. It stops exactly where it is. I could write this as a fraction if I wanted. I could continue with the decimal by adding zeros if I wanted. So this is a rational number, 15.1895407, rational. Okay. Next one we have is 2/3. I'm going to turn this into a decimal just so that we can see it. So 2/3 is the same as 2 divided by 3. 3 will not go into 2, so we add a 0. Or a decimal and a 0. 3 goes in 26 times, which is 18. Subtract, we get 2. Bring down another 0. Goes in 6 times. Subtract, we get 18. Or we get 2. And it's just going to keep doing that forever. So this is a repeating decimal, 0.66 repeating. But if it's repeating, can I determine what comes next? Yeah, it's predictable. Another 6 is always going to come next. So this is rational as well. I'm going to write it how they give it to me, 2/3. Next, we have a repeating decimal, 1.5353 repeating. If it's repeating, I know what comes next, so this is rational. We have the square root of 2. Now the square root of 2, what times what equals 2? Well, we start with 1. 1 times 1 equals 1. Move to 2. 2 times 2 equals 4. So we just completely skipped the square root of 2. The square root of 2 is irrational. It is not predictable. It is going to be a decimal we cannot find. The last one here, there's a little bit of a typo. There's like a little line there that shouldn't be there, but that shouldn't have bothered you that much. The square root of 9. What is the square root of 9? Well, the square root of 9 is 3. This is a counting number, so this is a rational number. So the only number here that was irrational was the square root of 2. Check your work with my work and let me know if you have any questions. Question number 2 says, which of the following is the best description of the number 7.3831439 ... So the one thing you really need to pay attention to here is the ... That means it's going on, and we don't know what comes next because there's no line over top, right? So this goes on forever, and we cannot predict what's going to come next. That makes it a irrational number. So this is irrational. Okay? And it's unending. We also call this non-terminating. Okay? So this is not a counting number. This isn't an irrational number. This is not a rational number. Not a rational number. The only one of these that even describes this even a little bit, that's our answer choice, is B. Okay? Moving on. Number 3 says the rational number 11.8 is the best approximation to the nearest tenth of which irrational numbers. We have 4 irrational numbers off to the side. This is actually a typo because some of these are rational. So of which number below? I should just say that. So the first one, we have the square root of 40. Now, I don't know where the square root of 40 lies on a number line. I don't know what number that comes in between, but I'm just going to list square roots that are close to that. So I have 12, which is the same as the square root of 144. I have 11, which is the same as the square root of 121. I have 10, which is the square root of 100. So all these numbers off to the side fall within this range, so that's why I started with those numbers. So the square root of 140 is going to be probably right before this 12, right? The square root of 135, this is going to be probably a little bit less than that, maybe right over here. The square root of 144 is going to be directly on the 12, and the square root of 121 is going to be directly on the 11. So I know that I'm looking for 11.8, so it's not going to be the one that's directly on the 11. It's not going to be 121, and it's not going to be 144, the one that's directly on the 12. It's going to be one of these decimals that's in between 11 and 12. So how can I figure out, is it going to be closer to 140 or closer to 135? Well, I'm going to take this number, 11.8, and square it and see which one of these does it come out to be closer to. Okay, so I have 11.8 squared. So 11.8 times 11.8. And I'm going to do this math out by hand. 8 times 8 is 64, carry the 6. 8 times 1 is 8, plus 6 is 14, carry the 1. 8 times 1 is 8, plus 1 is 9. Done with that 8, we put a space holder. 1 times 8 is 8, 1 times 1 is 1, 1 times 1 is 1. Done with that 1, put 2 space holders. 1 times 8 is 8, 1 times 1 is 1, 1 times 1 is 1. Math isn't too difficult here. 4 plus nothing is 4, 4 plus 8 is 12, carry the 1. 9 plus 1 is 10, plus 8, 18, plus 1, 19. Carry the 1, and 3 ones is 3, 1 1 is 1. We have 2 spaces for our decimal. So 11.8 is the same as the square root of 139.24. So what is that closer to? 140 or 135? Well, this is closer to 140. It's closer to this one right here on my number line. So A is the correct answer here. Okay, let me know if you have any questions before we move forward. Number 4 says, which of the following statements is true? The square root of 8 is between 4 and 5. 2 times the square root of 5 is between 7 and 8. 5 times the square root of 3 is between 9 and 10. And 3 times the square root of 9 is between 8 and 9. So what I'm going to first do is create a number line with the numbers they give me, 4 through, what does it go up to, 10? So I'm going to go 4, 5, 6, 7, 8, 9, 10. I went a little bit overboard. Put an 11. And I'm just going to write what these actually equal in terms of square root. So 4 is the same as the square root of 16. 5 is the same as the square root of 25. 6 is the same as the square root of 36. 7, square root of 49. 8, square root of 64. 9 is the same as the square root of 81. 10 is the same as the square root of 100. 11, 121. Okay? So that's going to help me as I fill in my number line. I'll know where to put these little things. So the first number I'm starting with is the square root of 8. Now the square root of 8 is going to come way before all of these. It's going to be before the smallest one we have here, which is the square root of 16. So the square root of 8 is going to be somewhere over here. Now, is that between 4 and 5? No, that's before 4. So this is not true. It's not between 4 and 5. It's before 4. Next, I have 2 times the square root of 5. So I'm going to write this off to the side. 2 times the square root of 5. And this looks a little bit confusing now, but what I'm going to do is I'm going to take this 2, it's on the outside of my radical, and I'm going to put it back inside, because that's how all my numbers down below look. And so to do that, I have to square my 2. So 2 squared is 4. And don't forget I had that 5 in there as well. So now this becomes the square root of 4 times 5. 4 times 5 is 20. So this is the same as saying the square root of 20. So the square root of 20 would be right in between these two numbers, the square root of 25 and the square root of 16. The square root of 20 is going to be right in there. So it's falling in between 4 and 5. My answer choice said it fall between 7 and 8, and that is not true. It is between 4 and 5, so B is not correct either. Okay? Moving on to 5 times the square root of 3. So I'm going to do this up top as well. 5 times the square root of 3. Well, I want to move this 5 back into the inside of the radical, so I'm going to square it. 5 squared is 25, and I still have that 3 in there, so I have to multiply those together. 25 times 3 is 75. So where would the square root of 75 fall? Well, it's going to fall right here in between 64 and 81. This is going to be the square root of 75. So this is between 8 and 9. My answer choice said it was between 9 and 10, so this is not correct. It's actually in between 8 and 9. All right? And the last one I have here, obviously this is going to be my one that is true. It says 3 times the square root of 9 is in between 8 and 9. So I have 3 times the square root of 9. So there's a couple ways you could solve this. You could move that 3 back to the inside, and I'll do that right now. So 3 squared is 9. So this would be 9 times 9. 9 times 9 is 81, so this is the same as the square root of 81. So this is going to be right here on my number line. Or you could have just actually solved it. So 3 times the square root of 9, well, the square root of 9 is 3, so 3 times 3, 9. Either way, it falls right here. Is that in between 8 and 9? Yep. It's kind of technical if you get into the wording of it all. It's actually not between 8 and 9. It is right on the 9. But this is our correct answer here, okay? All right, take it with mine and see if you have any questions for me. Question number 5 says, what is the sum of the expression? So we're just going to find this out. Well, what is the square root of 9? The square root of 9 is 3. What is the cubed root of 27? What times itself 3 times equals 27? 3. 3 times 3 is 9. 3 times 3, or 9 times 3 is 27. So we're doing 3 plus 3. So the sum of this expression is 6. Okay? Let me know if you have any questions, and we're going to move on. Question number 6 says, select all values that are between 4 and 5. Mark all that apply. So starting with A, it says the square root of 50. Well, what is this closest to? This is closest to the square root of 49, which is 7. So this is around 7. Okay? It's a little bit more than 7, but here's the deal. It has to at least be 7. So is it going to be between 4 and 5? No. It's not going to be A. Next one, the square root of 40. Well, what is this close to? Well, it's close to a perfect square of 36, which is 6. But it's more than 6. If it's more than 6, it's definitely not between 4 and 5. Okay? The next one, we have the square root of 30. Well, this is close to the square root of 25. This is my perfect square for 5. But it's more than 25. It's 30. It's the square root of 30, so it's bigger than that 5, so it is not in between 4 and 5. Okay? Next, we have the square root of 20. Square root of 20. The square root is in between two perfect squares. It's in between the perfect square of 16 and the perfect square of 25. And remember that the perfect square of 16 is 4. Perfect square of 16 is 25. So is it in this range between 4 and 5? Yes. D is my answer. But it says select all values, so I could have another answer here. All right. E is the cubed root of 100. So I'm going to do this one off to the side. It says the cubed root of 100. So I'm going to just list my cube roots off to the side because I don't know what this would be. So 2 cubed, 2 times 2 is 4, times another 2 is 8. 3 cubed, read this on the last slide, this is 27. 4 cubed, 4 times 4 times 4 is 64. 5 cubed is 125. So this number is going to be in between these two because this is our range. And so our answer is correct. It is in between 4 and 5. It falls within that range between 64 and 125. So E is one of our correct answers. Next, we have the cubed root of 110. Well, is 110 still in between 64 and 25? Yeah, it still is in between those two numbers, so it's still going to fall within 4 and 5. So that is correct. And then lastly, we have 2 times the square root of 10. Okay, so what I'm going to do is I'm going to take this 2 that's on the outside of my radical, and I'm going to put it back to the inside. Okay, so to do that, I do the opposite of taking the square root. I square it. So 2 squared is 4. So I now have a 4 in here, and I still have my 10 in here, so I have to keep that times 10. 4 times 10 is 40. So 2 root 10 is the same as the square root of 40, and we actually already did this one for b, right? And we determined that was not a square root there, or that was not between 4 and 5. That was too high. Okay, so go ahead and check this with mine. Check your work with my work, and we will move on. For number 7, it says what fractions are equivalent to 0.88 repeating. So I'm just going to turn all of these fractions into decimals. So it might take a while because we have to do it by hand, but it's a process that you know how to do. So I'm going to start with my first one, 8 over 9. This is the same as saying 8 divided by 9. 9 does not go into 8, so I put a 0 on a decimal. 9 goes into 80 8 times, which is 72. And we subtract and we get an 8. Bring down another 0. 80 goes into it 8 times, which is 72. We subtract and we get 8. And we have a pattern. So this is the same as 0.88 repeating. So A is one of our answers. Okay, B, it's 14 over 11, or 14 divided by 11. 11 goes into 14 one time. 14 take away 11. 11, 12, 13, 14 is 3. We add a decimal point. We get a 0. 11 goes into 32 times. And I'm actually just going to stop here because I already have 1.2 as my answer. My answer is never going to say 0.88. It's just going to keep going 1.2 something. So B is not my answer. C, I have 24 divided by 27. Well, 27 will not go into 24, so I put a space holder, or I put a 0. 27 going into 240. Well, I got to do some math there, so I know 27 times 10 is 270. So I'm going to try 27 times 9, see if that works. 9 times 7 is 63. 9 times 2 is 18, plus 6 is 18, 19, 20, 21, 22, 23, 24. So 243, that went over 240, so it's going to be 27 times 8, and I need to figure out what that actually equals. 8 times 7 is 56, carry the 5. 8 times 2 is 16, plus 5, 17, 18, 19, 20, 21. So this goes in 8 times, and my answer is 216. I do my subtraction, borrow from my 4. 10 take away 6 is 4. 3 minus 1 is 2. 2 minus 2 is 0. Bring down my next 0. And I'm back at 240 again. So we know that 27 goes into 240 again 8 times. And you can see that this is going to keep repeating, right? So C is one of my answers. Okay, moving on to D, 12 over 5. This is the same as 12 divided by 5. 5 goes into 12 2 times. I already know that this is not going to be one of my answers because I have a 2. 5 goes into 20 4 times. So this is 2.4 as a decimal. This is not my answer. Okay, next one I have 40 divided by 45. Well, 45 will not go into 40. 45 going into 400. I'm just going to guess 8 because I'm trying to see if it matches this. So if it does, I'll keep going. If it doesn't, if it's a different number, then I'm going to stop right there because I need to get an 8. So 45 times 8. Let's see what it comes out to. 8 times 5 is 40. 8 times 4 is 32. Plus 4, 33, 34, 35, 36. So it's 360. Okay, so that might be the one, but let's try 9 and see if it goes over 45 times 9, 9 times 5 is 45, 9 times 4 is 36, 37, 38, 39, 40. Yep, that goes over. So it is an 8. So I'm going to have to keep going because I think that this might be my answer. So 45 times 8 was 360. I subtract. I get 40. Bring down a new 0. And yes, this is just going to keep going. It's the same numbers as before. It was 400. So this is one of my answers, 0.88 repeating. And the last one I need to check is 9 over 7. So this is the same as 9 divided by 7. 7 goes into 9 one time. I can already see that this is not my answer. 7 goes into 22 times. And you'll see it's already at 1.2, so this is not correct because it was 1.2 something. Okay, so the correct answers here were A, C, and E. Check your work with my work, and we will move to the next question, number 8. All right, number 8 says, draw a line from each expression to a point that represents it on the line. So the first one we have is 3 pi. So 3 pi is the same as saying 3 times 3.14 ... I'm just going to leave it at 3.14 because I'm estimating where it could lie. If I have like 2 points that are pretty close together, I'll just leave this one for the end. 4 times 3 is 12. 3 times 1 is 3 plus 1 is 4. 3 times 3 is 9, and I am 2 decimal spaces in, so it's 9.42. So it actually looks like there's only 1 point that's after the 9. So this is going to be my point D. Okay. Next, I have the square root of 20. So the square root of 20. Well, that's not a perfect square, but I know it comes in between 2 perfect squares, right? The one that comes right before it is the square root of 16. The one that comes right after it is the square root of 25. And these numbers equal 4 and 5. So the square root of 20 is somewhere in between 4 and 5. Is there any point that's in between 4 and 5? Yeah, this point B is directly in between 4 and 5. So this is representing point B. Next, I have 2 times the square root of 15. So 2 times the square root of 15. Well, I'm going to start with the square root of 15 first. I'm going to say, what does this fall in between? Well, this falls in between the square root of 16 and the square root of 9. So this is in between 4 and 3. Okay? So this inside here is going to be in between the number 3 and 4. So I'm going to find my limits. So the limit for my small side is 3, limit for my large side is 4. So it's going to be 2 times 3 for my small side, so it's in between 6, and 2 times 4 for my large side, 8. So it's in between 6 and 8. Here's my range right here, 6 and 8. Is there any point that falls in between 6 and 8? Yeah, point C. And then lastly, obviously this is going to represent point A, but we just want to make sure that we haven't done anything wrong here. So the square root of 2, this is irrational. There is no square root of 2 that we can predict, but the square roots it falls in between are the square root of 4 and the square root of 1. The square root of 1 is 1, the square root of 4 is 2, so it's in between 1 and 2. Is this point A in between 1 and 2? Yep, it is. So that goes there. Okay? Any questions here? Let me know in the chat, and then we'll move on to question number 9. All right, for number 9, this question is a little bit more difficult than the ones in the past that we've done, and quite frankly, I don't agree with this kind of question being on the test. I think it's a little bit too difficult, and the standard doesn't really match it in my opinion, but again, I don't create the test, so we're going to start with number 1, and we're trying to find a number that's in between the square root of 6.5 and the square root of 7. Now, we don't know what the square root of 6.5 or the square root of 7 is, but we know what perfect square roots they're close to. So the perfect square root that is bigger than both of them, that's right on the other side, is the square root of 9, and the one that's on the other side is the square root of 4. So remember, this equals 2, and this is 3. So it's in between 2 and 3. So what we're going to do is we're just going to have to do guessing and checking for decimals in between 2 and 3 to see if we can get a number to fall in between the square root of 6.5 and the square root of 7. So I'm going to start with 2.5 because it's right in between 2 and 3. It's 2.5 times 2.5, or 2.5 squared, 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. Place a 0 for my space holder. 2 times 5 is 10, carry the 1. 2 times 2 is 4, plus 1 is 5. And I'm done with this. This comes out to 625. My decimal is 2 spaces in. Is 625 in between 6.5 and 6 and 7? No, it's too small, right? It has to be above 6.5. So I'm going to try maybe 2.7. Skipped a couple. And we'll see if this one works. 7 times 7, 49. 7 times 2, 14. Plus 4, 18. Space holder. 2 times 7 is 14. Carry the 1. 2 times 2 is 4. Plus 1 is 5. Add these up. 2 spaces in. This one's too big. So I'm going to try 2.6. It's crazy how one little decimal place can change the number so much. So 6 times 6 is 36. 6 times 2 is 12, plus 3. 13, 14, 15. Space holder. 2 times 6 is 12. Carry the 1. 2 times 2 is 4, plus 1 is 5. We have 6, 7, 6. So I got 6.76. So is this in between 6.5 and 7? Yes. So the square root that goes in the middle here, the number that's in between those two, what rational number sits in between? 2.6 is in between those answers. Okay? All right. The next one, 38 and 39. So these are close to the square root of, well, 36 I know comes before it. The one that comes after it, 7 times 7, 49. So it's in between 7 and 36, 6. So 6 and 7. So I'm going to start with 6.5 again, right in the middle, to see which way I need to go. 5 times 5 is 25. 5 times 6 is 30, plus 2, 32. 0 for my space holder. 6 times 5 is 30. Carried 3. 6 times 6, 36, plus 3, 39. Done with that. And 2 decimal places in, so it's 42.45. This is too high, so we need to go less than 6.5. Let's try 6.3. 3 times 3 is 9. 3 times 6 is 18. 6 times 3 is 18. 6 times 6 is 36, plus 1, 37. 2 spaces in, and I'm at 39.69. It is just a little bit too high. It's above 39. So I need to go one less, 6.2. This is probably going to be the one that works, or one of them that works. 2 times 2 is 4. 2 times 6 is 12. 0 for my space holder. 2 times 6 is 12. 6 times 6 is 36, plus 1, 37. And I'm 2 decimal places in. So 38.44 falls in between 38 and 39. So the answer that I multiplied, the number that I squared, was 6.2. That's what came in between. So again, a lot of math here, but it's just guess and check work. And you will have a question like this on the test. It'll be different numbers, obviously, but just make sure you can do this, okay? Let me know if you have any questions, and that is the end of our study guide. What we're going to do now is do some goal setting and figure out areas that we need to study for the test tomorrow. All right? Good luck.